Hi everyone, good evening. Okay, I'll share my screen once again. Okay, okay, let's begin where we had left yesterday. So yesterday we were discussing on mainly on the lab activities that were that, that were for the descriptive statistics. Okay, yeah. So yesterday we extensively covered mainly on that the sampling error, and then we even look into this the sampling technique, one of the method called the stratified sampling, how we will do that. Then after that we covered about uh, the various scales of measurement, mainly on the nominal, ordinal, then the interval and the ratio. Then we looked into the various examples. So then we studied, mainly took the data set, then we understood how the data is has to be uh, how we need to study about the attributes based on what kind of scale of measurement we have, correspondingly how we can use them. Okay, so then we went into the descriptive statistics also, and this where we had left. Let's begin with this. Okay, so yesterday I was discussing about the mainly on the mean. Okay, so we made the statement that the mean is not the center of the distribution range. This we discussed. Okay. So when we talk about the mean, basically when we have a distribution, so usually what happens, we have a distribution, we have a distribution, and the mean would will be the center point. What will be the center point? It means that the total, the sum of the distances on the left side of the mean will be equal to the right side of the mean. Okay, so that we call as a center. Okay, even this gets deviated or it gets affected when we have when the distribution is not purely a normal. So basically what happens, this could be because of the skew data. So if this the mean function may not be uh, with the right the central tendency. Okay, so in that case what we have to do, we have to consider other the descriptive statistics for the central tendency, mainly on the mode and the median. Okay, this we discussed yesterday. Then okay, this is what yesterday I shown you that. Then we also looked into this mean as a balance point, where so we just consider around 5,000 different distributions. So because earlier what happened, I had considered only one distribution. So this could be the getting that center point, probably because of the kind of data what we have selected. So we wanted to test it. So that is the reason what I did. I took the 5,000 different distributions. Then in each distribution, I have generated 1,000 numbers. Then again, what I have done, I have calculated the mean for those 1,000 numbers, then evaluated what is the total sum of the distances from the mean for the respective observations on the left side of the mean as well as from the right side of the mean, and we evaluated what is the balance. So if you take this is the source code which I have written, though almost all the 5,000 had the equal distances, then it pure truly indicates that. Okay, so the 5,000 distributions is equal to the total distance of the values below the mean. Okay, so that's what we have studied. Now let's begin with the next activity. Like we imported the same data set. Sorry, now we imported the one of the housing data set. Okay, so let's see what we want to do here. Okay, then house is one of the variable called sale price, and that is a numeric. The numeric, okay, the sale price, and we describe this. And what is this? The count is around 2930. This is my mean value. Similarly, we have all the 5 point summary for this particular series, that is sale price. Then if you take this mean, and what is my pandas mean, that is also same. So 180, 796. Okay, so next is that estimate the population mean. Okay, now this is my mean. Already I have done it with my panda function. Okay, now what we'll do, I have taken a sample size as 5. Then for the range of 100, okay, means that for the various 100 samples, what I have done with that same sample size 5, I'm generating the samples. That's with call it a distribution or a sample. Then I take the sample mean. Then what I will do, I will take the difference of the mean parameter, and now this will be my population. This is my population mean, and under this I'm calculating the for the different samples, I'm calculating the sample mean. Sample mean, okay. Then the sample size append, okay, fine. Then I truly consider what is the sampling error, okay, and I'll just collect this, all this, okay. Now what I will do, I want to plot this actually, okay. So if you see this, this is my plot, how it looked like. Now all these data points, what is happening here? All these data points are nothing but the sampling errors. These are your sampling errors, and this horizontal line, the green one, if you see this, that is a green one, is your the population mean, means that is the center actually. Okay, means that all these sampling errors, when we increase the number of the samples, okay. So what is happening? Everyone is going towards this, means that earlier, if we just go bad side, the sampling errors dot append, okay, the mean parameter minus the sample size, okay. And what is happening here, the sample size is going to change now, okay. Means that earlier when I change I am just moving one by changing the sample size, okay. For that sample size, I'm calculating the various the sampling errors, okay. So it means that, so if you consider this as a population mean, initially with a less number of population sampling size, I will be away from the population mean. Okay, I will have a higher sampling error. So when I increase it, so automatically what happens? I will be tending towards the population mean. Okay, so that's what we are trying to estimate the population mean based on the sample. Okay, so that's what we are saying. In any statistical survey or in any statistical analysis, will never have the population data, okay. So but our ultimate goal is that we want to estimate the population parameters, which we already discussed, but always we will be dealing with the sample. So it means that, so we have to perform the same analysis activity on the different samples, okay, so that only one sample statistics may not suffice our the goal actually. See, we need to perform the activities on the various samples and take the averaging of it, then only we'll be able to move towards the population estimates, okay. Yeah, see, visualizing the distribution of sample means, what is happening here, the most sample means cluster around the population mean, okay. So what is happening here, I'm trying to take the samples here, sample mean, And if you see this, the red one, this is actually your population mean. This is your population mean. But what we are trying to, this is a histogram plot. Okay. So these are all a sample mean. For that sample mean, we have taken the histogram. Means that if you take around 10,000 of samples with a sample size of 3, there are around 10,000 of data. For every sample, we have taken the mean. Okay. So it means that I will have a big list of the means, that is around 10,000. Okay. And for this 10,000, what I will do, I will plot the histogram. Once I do this histogram, so what will be my the center point? Okay. So it means that this is my population mean, and this is my mean what I get it from the sample of means. Okay. So what we want to understand from this is most sample means cluster around the population mean. Okay. Yeah. Then with a sample size of 100, the sample means very much less around the population mean than in case of sample 3. Okay, so it means that when we try to increase the sample size, earlier we are working on a only sample 3. Okay, so still there are a lot of variations, you can see this. But when we increase the number of samples size from 3 to 100, automatically our histogram will shrink. And so you can see this plot. Okay, means that you need to have more number of samples if you want to move towards, because ultimately when we have more number of samples in the more number of observations in a sample, it indicates that mm, we'll have the lot of characteristics of the population data, so that our sample will look better as compared to the population. Okay, so that's the meaning of that. So here important is the sample mean is an unbiased estimator of the population mean. What do you mean by an unbiased? Okay, so here an estimator of a given parameter. What is an estimator of a given parameter? Means that now in this case, here it is my population and this is my mu, and here it is the sample and here it is x bar. Okay, that's what I want to. Now x bar from the sample, I want to estimate this. Here an estimator is nothing but your x bar for the given parameter, that is mu. Okay, is said to be unbiased. This is a sample mean is said to be unbiased if its expected value is equal to the value of the parameter. What is the expected value? Means that you are going to consider many samples, and from the samples means I am going to estimate, means that I am taking to take the average of that. E of, okay, E means that here in the case of expected value, it indicates it's nothing but the average. Average, okay. The average of means of all the samples. Okay, if that value is tending towards or it is equal to the population, is equal to the true value of the parameter, okay, then it is getting unbiased. Okay, so this is not the, it's an unbiased estimator of the population mean. Okay, there is a, just think this bias and unbiased means that it is not biasing, means that we don't have any error, but it's unbiased condition. The sample mean is an unbiased estimate of the population mean. Okay, so if you take these various samples we have taken, okay, and what we are doing, and this is our population, the various combination of the population, for example, now we have 3 various combinations we have made over here. Then what we have done, for each, if for each sample I am going to compute the mean, then what I will do, I will append it to the sample means. Then at the end what I will do, okay, I will take the total sum, the sample means divided by my length of means, then mean of the sample means. Now this, whether this mean of sample mean is equal to the population mean, that we have to calculate. Here we are doing it. Population mean is equal to mean of the sample mean, and we are getting it as a true. It means that, so the population mean is equal to the mean of the sample means. That is the reason we can call it as sample mean is an unbiased estimator of the population mean. Okay, hope you understood this. Okay, this is about the samples. Okay, and the mean and the descriptive statistics mainly. Let's to discard. Fine. Okay. Now let's work on the lab on. Okay, the measures of variability. You know this. We looked into the various measures of variability, mainly the range. So we started with the what are the measures of variability which we looked into as a part of the descriptive statistics. So first one was range, we looked into it. Then second was interquartile range, we looked into it. Then there was third was on the variance, and the fourth one was standard of deviation. Okay, so we didn't cover, we looked into only the scale examples, how we can do it manually, but let's see how we can work on the lab activities and what we understand from the lab. Okay, now we'll be working with a data set that describe the characteristics of houses sold between 2006 to 2010 in the city of Ames. Okay, so there is a the data is collected for the mainly on the houses which are sold between 2006 to 2010. Okay, so there are around 2,930, almost is equal to 3,000 rows in the data set, and each row describes a house. Okay, so for each row, there are certain characteristics which have been captured and created a data set. And if you see this, there are around 82 characteristics. So nothing but there are 82 attributes for this data set. Okay, so this is related to the housing. Fine. See here, AM's housing .txt file, which I have already imported. In the earlier also, I have shown you this particular data set. This is you are going to include. Okay, there are, as I said, there are 82 attributes in this data set. Fine. Now let's take the range. Now if you, let's take the range, how you going to calculate the range? That is again very simple. When you have any kind of numerical data, so the minimum and the maximum, we need to find out the and take the subtraction from the max. So we'll have the complete range of for that particular attribute. For example, now there is a small function called a find range which I have written. So that is an array, and it will take an array and we calculate the max of array and the min of array, and this will return the value of that. Okay, now I will take one uh, houses year sold unique. When you see this, this is a categorical data, because when the particular house was sold, so that particular year has been captured. So definitely this is your categorical data. Okay, so if you see this categorical data, this is a nothing but your nominal one. This is not an ordinal, this is your nominal data. Okay, because there doesn't have any hidden uh, order. Okay, so rank is involved. Okay, is purely a nominal data. Now what we'll do for this per year basis, okay, then we'll take the houses year sold is equal to sales for this year sold. Okay, for that particular year, because this particular house has the all data for all the years. Okay, but what we have to do, you have to put a condition and capture only the data for that particular year. So now we are interested on the sale price. As you know, sale price is your numeric data, and what we are doing, and for that year sale price we are going to calculate range by year. Okay, so this is my range by year, how it looks to me. Okay, so you can see this. I'm just calculating the range of data, and basically we can come up with the inference like how my data actually uh, go in a range. But again, there are some very good functions are available with this. This all not required for us. Suppose if I go with just a describe call, automatically all the information will be available for me as a 5-point summary. Using that data, I'll be able to do perform my next analytical activity. Okay, so but it's only for the exercise. Fine. Then IQR, okay, interquarter range. I think I have covered this enough. Okay. So there is interquarter range. You know it already what we do in this. So when you have a numeric data, so we calculate the median. Then once we calculate median, automatically it get halved. Okay, means that two parts. In the first part, then we go for calculating a median here. Then we go for calculating median here. Now this will become your Q2. This will become your Q1, and this will become a Q3. Now the interval quartile range is nothing but your Q3 minus Q1. So that we call as IQR. This is what we calculate for every attribute. Okay. So basically what happens when you perform your the describe method for any of the data frames. So I will have all these data. I will have a Q1, Q2 and the Q3. For IQR, you need to subtract and get this how my IQR looks like. Okay. Okay, this is how based on this IQR, we should be able to judge that how my data is dispersed from the mean. Okay, means that you should get more clarity on what kind of dispersion you have. Probably if it is Q1 and Q3 you have. Okay, so when you find out the median, definitely from this data, how much data is actually skewed or how much data is falling after the median, that all information will be able to based on the experience. Okay, so that is about IQR. I don't have much, I don't want to cover much here. Okay, so let's get into the variance. As you know, this variance describes how much random variable differs from the expected value. Okay, so expected value is nothing but your mean. Okay, this is how we calculate it. So how do you calculate the variance? Variance is nothing but your S square. Okay, so initially what you have. So if this is my attribute and if this is my xi, okay, where I equal to 1, 2 up to n. Now what I will do? I will take this each observation xi and I will before this I would have calculated my mean. How you have calculated the mean? X bar is equal to summation of I equal 1 to n. Take the full the summation xi and divided by 1 by n. So this is how I would have done my the average, that is x bar. Then what I will do? I want to know that how each observations are move away from the mean. So in order to do this, I have to consider every observation that xi minus x bar I have to do. Okay. Now if I do this, what will happen here? If I just plot it something like this, now this is my mean, this is my x bar. Okay. This is how it looks like. Now, the thing is that when I subtract it from the mean, there could be chances that there could be a plus and there could be a minus. Okay. If I add it both, actually I'm not uh, considering because it would get cancelled, right? So what happens that I will not be able to consider the correct value of that because of the negative. Now what I have to do, instead of taking that negative value, let's make it a square. Okay, once we make it a square, automatically all my negative values will become a positive for me. Okay, then anyway, see, I'm not going to do any kind of calculation on that, but I want to understand only that how much variance in the data for different data set I need to compare, correct? So whether it is a higher, uh, whether it is a bigger value or a smaller doesn't make any difference. But what I have to do, I have to make it a more positive so that every distance from a mean I need to consider instead taking the negative value of that. Okay, that is the reason I make it as an x square. Then what I will do, for all these observation what I have calculated, I will do the summation, that is from I1 is equal to n. Okay, then what I will do after this, I will divide it by n. Fine. So this is what we are doing, and since it is a sample, then we generally perform the n minus 1. When it is a population, we do it for a n. That will cover why we want to do that. Okay, so this is how we calculate the variance. Do you see this? What happens when I'm doing this s square minus this is squaring again, right? So what happens here? The if you take this unit, for example, now think that this is I'm calculating certain distance. If they maybe in terms of kilometer, my xi minus x bar whole square, because xi is again the kilometer, okay, and this is also kilometer, so that I will get a kilometer, then I will square it. Okay, then it means that if you take this s square is equal to, it will be in the terms of kilometer square. Okay, and what happens, but the data what we are dealing with will be in the kilometer, but this will be a square. But we want something where uh, we want unit less metric for the comparison. Okay, we don't want have to the particular unit here. That is the reason what we generally do, we take the square root of it. Okay, we don't want this. Yes, when we come out of the when we put a square root and come out with a square, right? So then that will become your standard of deviation. Okay, that is the reason why is the standard, right? Standard means that we are normalizing it, means that we don't want any kind of unit associated with that particular metric. Okay, we want to make it unitless so that our comparison will be more easier. Okay, from if I want to compare for the kilometers with the meters unit, or maybe some other unit is there, what is the kind of the variance is from the mean. If I want to compare it, it's very difficult because the units are different. I will not be able to compare it. Okay, so we can make it unitless by taking the standard deviation. Okay, so that is the reason why the standard deviation is introduced, just putting a root of that, so that the complete your making that unitless. Okay, yeah. So in the variance, if you take what kind of variance, let's take C. Okay, simple functions which I have written, and first is average distance. Okay, what is this average distance? Here element minus mean you have taken. Okay, you just remember this much only, you just consider element minus mean. Here we have not taken any square. Okay, we are just taking element minus mean. So that is, if you take is 0 0, you got it. That's what I told. We need to put it a square so that my uh, the negative values will become positive for me. So that is the reason we have to put a square. If you make it just a without just considering all the plus and minus in my data, so because here we are going to do a sum, whatever we have done it here, we'll do a sum for this, automatically everything will get cancelled. So almost will return with a 0. Okay, yeah. Then mean absolute deviation we have taken, means that I am making everything as an absolute here. Okay, so this is also one form of deviation we can consider. Mean absolute deviation is that. Okay, so here I am making an absolute. When, for example, now whatever data we call it as, so the we make it absolute. Absolute we generally write it in mathematical like mod. So that will become my absolute data. Okay, then variance is that now after this element minus mean which I have taken, I just go for powering it by 2. So that when I square it, this is what I get it as a variance. This again a very simple function, and this we can always do it with your already we have in the pandas and numpy also you have functions for calculating variance and standard of deviation. So you can directly use them, but at least know that how we do this. Okay, in the standard of deviation, I already covered it, because this is your population variance is the average of the square deviation. He is strictly where I'm saying that population. That is the reason we'll have a n here. And what is my parameter? That parameter will be sigma square. Okay, and then I have to go for square root it. Okay, fine. So this is for the sample variance. Okay, that is the reason we have n minus 1 here. Then we calculate the standard of deviation by taking the square root. Fine. So if you take the standard of deviation, earlier we calculate for the variance. Now additional part is that only that square root. Otherwise, no changes in this. The same function we return it all the code. then I just put a square it over here. Okay, and try to implement your basic functions like this so that you'll have a very good understanding of the concepts of the statistics. Okay, yeah, this is how we do it. Okay, fine. Then if you take the standard of deviation for the sale price, this is around 79873, and if you take the mean also, it is around 18796. Okay, so what do you understand from this? Suppose this is my sale price. My mean somewhere it will be here around 79873. 79, oh sorry, it will be around 18796. Okay. Now when I say standard of deviation, somewhere it would fall. It could be an additional or it could be a subtraction. Okay. So that's what is roughly 798 above the or below the mean of 18796. 18796. It could be minus of 79873. It would be somewhere here or it could be somewhere here. So this is your one standard of deviation, SD. Okay. Yeah. Fine. Then visualizing the variability around the mean. Okay. Now think that what we are doing, I have taken the same sale price. Okay. Then mean I have calculated, and also I have calculated the standard of deviation for the same sale price. Fine. Now I want to plot this. Initially what I will do, I'll just go and plot the histogram for the sale price. And this is my histogram, how it look like. Okay, fine. And once I plot the histogram, what will be my mean? Now the black color indicates your mean. Okay, yeah, the mean. The black color indicates a mean, and your mean minus standard of deviation, mean plus the standard of deviation. Okay, the red and the violet. So this distance we call as 1 is D. Okay, this distance is called a 1 standard deviation. And this is my range actually, if you take this. Okay, so here within this 1 standard of deviation, this is how my data will look like. Okay, within the standard of deviation, what do you see? Almost if you see this, our plot will be almost around in the form of a normal curve. We'll discuss about this normal curve in future, but generally what happens within this 1 SD, okay, almost 68% of the data will be available in only this 1 SD. Okay, that is 1 standard of deviation. You can see this, almost all the data will be within this 1 SD. Okay, yeah, this is how we can visualize our variability around the mean. And same thing what we are doing here. Okay, uh, I have taken the years sold in the unique. Okay, then the sale price for every year, the greatest variability. So when particularly in which year we have the higher the variability. So that is for 2006, and the lowest variability is around 2010. So this we can kind of functions we can run it just to get an understanding for that sale price. When you take a sale price, this will be like a just a data, but inside this we want to know that actually for which variability, for which year so much of variability is there. Okay, so that we can do it like this. Now the standard deviation as a measure of spread. Okay, so what we are doing, again the same thing, right? See, for example, now I'm taking the range 5, then I'm taking a sample, and I'm performing the standard of deviation, and for various samples I'm doing this. So just to give an idea, like even for a sample also I'll be able to do this. But what is the motto here? Even I want to know whether it is an unbiased for the population standard of deviation or not. Okay, so the standard of deviation as a measure of spread, the sample standard deviation underestimates the population standard deviation. What does it mean? So it means that when you have the 5,000 distribution, I have taken the sample, and this is my standard of deviation for complete 5,000 distributions. Okay, now if I go and plot all my standard deviation for each sample, but red indicates my population mean. Okay, the red indicates the houses. If you take this, this is my population, this is my population standard of deviation. But actually, if you see this, for all the samples, somewhere it comes over here. So what does it mean here? So it means that there are a lot of deviation actually. If you see this, the 71303 and 79873. This is for the standard deviation for the complete 5000 distribution, but this is for the population. So there is a lot of differences there. Okay, so it means that there is a lot of deviations. We cannot, it underestimates the sample standard deviation, underestimates the population standard deviation. Okay, so in order to do this, what we have to do? Okay, so that is a question. What we have to do? If I want to reduce this particular range, because what happens, ultimate our goal is that we want to reach the or estimate the population standard deviation, or rather I would say the population parameter, by considering this sample statistic. Then in order to do this, there should be certain method where I need to fill this gap, right? So there is a function called as, there is a Bessel's correction. See, the Bessel's correction refers to this n minus 1, found in several formulas including a sample variance and the sample standard deviation. See, we do this like n minus 1, but you don't know why we are doing it. Okay, so generally that is the right way of doing it, is as 1 by n only, but we make it n minus 1 because this is because of your Bessel's correction. Okay, so that is only to reduce the gap between the sample statistic and the population parameter. Okay, this correction is made to correct the fact that these sample statistics tend to underestimate the actual parameters found in the population. Okay, so this should be your answer when why you are using the minus 1 when you're calculating the variance and the standard of deviation for a sample, because the sample statistics actually tend to underestimate the actual parameters found in the population. So that should be your answer. Okay, so that we call as a Bessel's correction, and we subtract 1 because of that. The calculations for both the sample standard deviation and the variance both contain a little bias. So what we do, we generally go and subtract by 1, we make it n minus 1 instead of n. Okay, so if you see this, I have implemented one function for the Bessel's correction. So here what happens, you can see this n minus 1 we have taken. But if I go and check in my earlier function for the standard deviation, okay, standard deviation where I have implemented, there is a length of distances what I have calculated. There is no n minus 1 here for the sample. Okay, so now what I have done, we have considered the n minus 1 because of the Bessel's correction. Okay, so let's see that how it looks like. Now you can see this, the Bessel correction earlier, this was my graph, so there was so much of gap was there. I have reduced the gap. Okay, so the red one indicates is my population standard of deviation, and this all the, you can see this for all the various samples which I've considered, and I calculated the standard of deviation and plotted the histogram, and I expect that actually in reality this should fall here actually in the center. Okay, so that's what, still because we cannot move an accurate way, but still we want to improve this. That's what this is a estimate, and what our sample statistics should get estimated towards this population parameter. Okay, now standard of deviation and variance in pandas and NumPy. Okay, so earlier we have implemented our own function, but how we can do it if we consider pandas and NumPy? And again, that is very simple. These are the direct the functions in NumPy like std and the var, and which I'll be generally using it. Okay, so for example, now what I have done, I have taken one houses sample for 100 observation, and for this particular sample, what I have done, I have calculated the standard STD and standard of deviation, and even for what is this, for the NumPy. Okay, NumPy and the pandas, I'm just calculating are they equal. Oh, you see this, they are equal actually. Okay, for NumPy and pandas, we can use any of that because the formula is implemented inside is same only. Okay, even that holds good for the variance also. Okay, and this DDF of is equates for if you want to do it for -1 or not. Okay, if you make it 0, that will be when. If you make it ddf of equal to 1 means that will be n-1. Then we sample variance as an unbiased estimator. The same thing earlier we evaluated for the mean. Okay, and here also standard of deviation. What happens here? Same thing here. We calculate the population variance as 6.0. Okay, see the sample variance as an unbiased estimator. Okay, but standard of deviation is not an unbiased. Okay, but only the variance is an unbiased. Generally our discussion holds good whatever we have discussed it for the mean, and the same thing for the variance also holds good. So what we generally do this, we generate a lot of samples from our population. Okay, then for each sample, okay, for each sample we are going to calculate the variance here. Okay, then we do the sum and take the length of the sample list, so that I'll get the average of the variance. So again I have got the 6.0, but what is my population variance? Population variance is also 6.0, so means they both are equal. Okay, so that is the meaning of what we say is an estimator of a given parameter is said to be unbiased if the expected value, that is expected value, that is what we do is the summation, right? So that is the expected value that is equal to the true value of the parameter. So again, both are equal. That is the reason we call a sample variance as an unbiased estimator. Okay, this is all about the lab about. Okay, one second. Okay, fine. So which we discussed about measures of spread, and which we discussed about the lab activity also. Fine. Then now, okay, yeah. Just a second. I will just go with one use case. Then I will start the new topic in statistics before closing this descriptive statistics. Okay. So what I will do again, that is again the same discussions. I'm just looking into that descriptive statistics. Again, the same discussion we have to do it. Otherwise, what I will do, I will share that IPython notebook with you. Okay, that is a use case. You can run it, because basically the same thing what we do generally. If we import the data set, then we perform all that calculation of the descriptive statistics. Okay, then I have given the inferences like what we understand from the descriptive statistics for that particular data set. Okay, and I'll give an exercise like for you. Just take a look and rerun that IPython notebook, and if you have any questions you can get back to me. And now what I will do, I will start on the next topic. Okay, the next topic would be, okay, fine, I'll share my share. Okay. Okay. Today we'll discuss on next topic of uh, after the statistics. Have to know on the probability and the Bayes theorem, and this will be using more on the machine learning and also the inferential statistics. Okay, so we have to have the good understanding on the probability, the basic probability. Then we have to understand on random variables, and we have to look into the various the distributions in the probability. Okay, after that we have to get into the again come back to the statistics. Okay, fine. Let's see what is probability. I think you might have been studied in the school days, even for the college, even in the engineering also. Okay, it will be just a refresh for you. So let's look into what is probability. Again, this probability is the measure of how likely an event will occur. Okay, means that there is an event and what is the probability of occurrence of that event. Okay, means how likely it is going to happen. Means that what is an event? That isn't just event is nothing but an activity. Okay, so that could be whether it is happening or not happening. For example, whether today it will rain or not. Okay, what is the chance of raining? What is the chance of a movie hit? Okay, so these are all the events we want to know how likely a particular event can happen, or how likely an event can occur. Okay, and usually what we do, let's see that how we can calculate actually in the probability. Okay, so here before this we want to know certain terminologies in the probability. Okay, so then that will become more easy for you to get through it. Okay, so there is a called as a experiment in this. There is a sample space and an event. Okay, means that take for example one experiment. What kind of experiment is that? Okay, for example, uh, throwing a dice. Throwing a dice. Okay, so throwing a dice is your experiment. Okay, throwing a dice is an experiment, and when you are doing or performing an experiment, there will be many outcomes of the experiment. Okay, and all this collection of outcomes, we call it as a sample space. Okay, outcome of this experiment. Okay, now throwing a dice is my experiment. From throwing of the dice, or it could be anything like playing cards, or you can take any kind of experiment. But what is that? The outcome of that particular experiment. Okay, there could be many outcomes out of the experiment. Then collection of all these outcomes, that will become your sample space. Then what is an event then? Okay, and again, one simple way of doing it is, the event is again, I can call it as a subset of the sample space. Okay, now if you take an experiment like throwing a dice, so what will be the outcome of the dice? For example, there are around 6 faces for the dice. I can get 1, or I can get 2, or 3, 4, 5, or 6. I can get any faces of the dice if I am throwing only one dice. If you take this as an experiment, now what happens? So now this all the outcomes, if I collect and put it together, then that will become my sample space. Okay, this is my sample space. Now how can I decide an event on the sample space? For example, think that getting even numbers like 2, 4, and 6. 2, 4, and 6. Now this will become my event. You can call it as an even. Okay, so rather what I have said, the even is now a subset of a sample space. Okay, similarly, I can define any number of events from the sample, for the sample, any number of events. For example, getting 1 is my event, or getting the divide by 3 or something like that. Okay, so see here, the number of outcomes are less. We can define very less number of events on this. Now we can increase the number of sample space. Suppose if I consider 2 dice, if I consider 2 dice here, what will be the combination of the 2 dice? This will be around 36 combination I will have. Okay, so I'll have a total 36 combination. Then I can increase the number of events. We can create a lot of events on that sample space. Okay, so that is the meaning of it. With an example, I hope these are clear for you. So what is an experiment, and what is a sample space, and what is an event? Okay, for example, that's what I'm trying to say. When we throw a coin, okay, here I'm giving a coin. Again, coin is very simple. It will have a head or the tail. Okay, when I throw a coin, I can get only these two options, head and tail. Now this will become my sample space. Okay, yeah. So what will be my event if I say event of getting an head? Okay, so this will be my H. I can tell E2 is equal to T also, event of getting a tail. Okay, yeah. So tossing a coin is a random experiment. Similarly, throwing a dice is a random experiment. And the throw a can, we cannot predict it at once whether it's upper face or that we know. Okay, we cannot predict that. Okay, that's what we want to learn in the probability. Means that once we have an experiment and once we have a collection of outcomes, and for that particular event, and we need to come up with our probability. Means that what is the chance of occurring of that particular event. Okay, so that's what the whole subject is all about. Fine. So in the event, out of the total results obtained by certain experiment, okay, that's what I'm saying here. So the total results, that is the total outcomes that has obtained from the certain experiment, the set of those results which are in favor of definite result. What do you mean by definite result? Means that in a sample space I have the outcomes, then for particular definite result, means that I'm looking for even number, or I'm looking for odd number, means that only for that, okay, for only for that objective we have a subset of outcomes of the main sample, then that we call as an event. That's what the meaning of that. So what kind of events we can have? Either we can have a disjoint event or non-disjoint event. So in the case of if you toss a uh, the toss a coin, so there could be a head and tail. Getting a head is an event and getting a tail is an event. At a time we cannot, at the same time we cannot have two events, right? So what happens here? So these two events are disjoint events. So they cannot appear at the same time. Means that they won't have any common things. Fine. There could be something like, for example, take in any event. For example, now you take in the dice. When I'm trying to throw a 2 dice, so I will have, if you take, there are 36 combinations I can get in the sample space, like 1 1, 1 2, 1 3, like that, 2 1, 2 2, 2 3, like this. Okay, at the end I will have 6 6. Okay, various combinations. Now, if you see this, for example, now I can define certain event here, like E1, and I can define certain E2 here. Okay. Now what happens? Now the sum of the two phases, it should be even. If I say this, then, or divide by 2. Let's take divide by 2. What happens here? So all these combination 1 1, 1 4. So many combination would appear over here. Okay. Now my second event, let's divide it by 3. If I take this, uh, like for example, 1 and 5 is there. Okay. In this, because these are 6 and this is divided by 2. Similarly, I'll have 1 5 also here, that is truly divided by 3 also. It means this particular outcome is part of the event E1 also, event E2 also. In that case, what happens? Rather, I would say this is your non-disjoint event, because there can have common outcomes for that event. In this case of head and tail, as I told you, there's purely disjoint. So no common things there. Okay. So that's about how disjoint event and the non-disjoint events. Even equally likely events also we have. See, equally likely means that every event, every outcome in an event. Okay. So for example, now you take this as an event. Every outcome what we have in the event, it will have equal chance. Okay, so there is no reason to expect happening one event preference to other, means that there are no preference are given to the outcomes. Okay, so means that everyone will have the same chance when the events are known equally. Okay, for example, uh, when an unbiased coin is tossed, the chances of getting a head or tail are the same. Okay, so means that take this for tossing a coin, what will be the sample space? Head and the tail. Okay, yeah. Now, what is the probability of H and what is the probability of T? So this will be 1 by 2 and this will be 1 by 2. Means that they have an equal chance. Means that there is a equal those are we call as an equally likely events. Okay, so okay, fine. This is about equally likely events. Then okay, so just a little more understanding on probability. As we said, probability, the chance of something will happen. Fine. So what will be the, if you see this is a diagram, what do you understand? There are only two situations. Means that there could be an impossible state or there could be a certain state. Means that take any event, whether it will happen or not, what is the likely, that we need to find out. There are only two conditions at the extreme. If you see this, whether that event will happen or not. Okay, means that whether today it will rain or not. Okay, it can happen or it doesn't happen. So if you take in the case of value, if you assign it to it, doesn't happen is equal to 0. If it happens, it is equal to 1. And in between, we can have many values. Okay, it means that when we have the 0.5, that is even chance. Okay, so here we are moving with a likely and here we are moving towards unlikely. Okay. Okay, that's what meaning of the probability. Fine. Yeah. Okay. What do we generally do this? Now we know the meaning of this, but we can assign the value to it. Okay. So now this is likely, this is certain, and this is impossible. Okay. Then we can move in this direction or we can move in this direction. Okay. And we can assign the values for this. Good. Then we can calculate all that. We'll see in the examples. Okay. And instead of the value also, we can assign certain percentage between 0 to 10% also. We can say that there is a chance of 50% chance that tomorrow it will rain, or tomorrow what kind of forecasting of the weather, what is the chance of raining, or even what is the chance of the movie is getting hit. Okay, so all this, whether we can go with the probability in terms of the fractional values or when we can go with the percentage values. Okay, so I'm just giving an example here. A jar contains 60 equal sized marbles. Okay, so now this is my jar. In this jar, I have a total 60 balls or marbles, you can say. So here what happens, out of the 60, I have two kinds of marbles. One is 35 and another is 25 of a different color. 35 are, of which 35 are white and 25 are, I'll just W, and 25 are black. Okay, now let's see. List all of the possible outcomes. So what is the, suppose now what is, you take one from the jar without looking. Okay, so with a closed eye, you want to pick, there are around 60 balls inside. See, what are the possible outcomes here? If you see this, you know this, there is a coin is there. When you toss a coin, what are the possibility are? Head and tail. These are my two outcomes. I can definitely tell. In this situation, what will be my output? What will be my sample space? I have only two sample space here, only two outcomes. Either I can pick the white ball or I can pick the black marble. Okay, W or T is only the possibility. Okay, there are only two possibilities. Then if you see what is the probability of picking a black marble, means that if I want to, I can, like, similarly, the probability of H is 1 by 2. The probability of tail is 1 by 2. They have the equal opportunities. Means they have an equal opportunity. So that's what I was discussing. Equal opportunities are equally likely events. But in this case, are they equally likely? Okay, let's see. Are they equally likely? Now, what is the probability of picking white and what is the probability of picking black? So now what happens if I want to calculate the probability? So this will be around 35 by 60 because there are total 60 balls. Okay. In that 60 balls, I want to pick 35. Here also I have 25. I want to pick 60 out of it. It means that there is a higher chance of picking white balls because more number of white balls are there. Okay. So it means that these are not equally likely. What is the possibility of picking black and what's the possibility of red marble? Okay. So that's what we have given here. Okay. Sorry, red marble. We don't have any red marble. That is the reason I was considering it as a different color. Okay. Fine. No issues. Okay, so because we don't have any red ball, that is the reason the probability is 0 here. Okay, fine. So there are two possible outcomes. The marble would be either black or white. So same thing, whatever I discussed. What is the probability that a card drawn from a pack of cards will be? Okay, okay. When you say that cards, the playing cards. So you know this. Let's what is a red card, what is a picture card, and an ace. Before knowing this, we need to have an understanding on the spare. Okay, what kind of cards we have. So generally in the pack of cards, there will be around 52 cards. And those 52 cards will have the four suits, the clubs, hearts, spades, and the diamonds. Okay. And in every suit, there are 13 cards. In every suit, there are 13 cards. And each 13 cards will be from A to 10 and Jack, Queen, and the King, additional cards. Okay, so that you have to know. Now let's come back. A red card. What do you mean by red card? So definitely this one red, this one red. The total are around the 26. So 26 by 52 will be my answer. Okay, so for this one, it will be 26 by 52. When you pick any red card, this is the probability. What about the picture card? See, here clubs is there, here spades is there, and hearts. So I'm not getting about that what kind of the picture card he's talking about. Let's see that. Probably picture card would be J, Q, and K. Okay, if you take this, let's leave about A here. Okay, just take it 1, 2, 3. It means that in every even if let's consider A as also a picture. If you do this, so in every suit there will be 4 cards. Okay, 4 cards. What will happen? 4 into 4. So for this one, it will be 4 multiply 4 is totally divided by 52. So this would be our probability. And ace is again simple. In every suit, there will be only one ace. So that will be 4 by 52. This is the probability. Okay. Yeah, see, correct. There is a 26 by 52. And over here, A, J, Q is there. Good. So we are right. Then this is 4 by 13 and this is 4 by 52. Okay, so this is how we calculate the probability. By these two examples, I think you should be knowing it like what we are calculating here. Means how we can calculate the probability. Okay, now let's talk about the disjoint and the mutually exclusive outcomes. Earlier, we talked about the disjoint events. Okay, so means that the outcomes of each event will not overlap when we call as a disjoint events. Okay, then we are talking about now disjoint and mutual outcomes. The two outcomes are called disjoint, okay, or mutually exclusive if they cannot both happen at the same time. Okay, suppose if you roll a die, the outcomes of 1 and 2 are disjoint since they cannot happen at the same time. That is correct. See, calculating the probability of disjoint outcomes is easy because they won't appear at the same time. So there will not be any dependency from each outcomes. Okay. So again, what happens when you have the two disjoint events? When you want to calculate the probability, what will be the total probability? So for each disjoint event, if we just add up, so definitely that is a total probability. For example, think that the if your die, even if you take the dice also, what is the probability of getting 3 and 4? If you take this, what is the probability of getting 3 and 4? So now 3 and 4 means this will become your R. Either you're calculating for 3 or the 4. So for the P it is 3 is 1 by 6, and again this will be 1 by 6. So it will be 2 by 6, rather it will be 1 by 3. That is the probability. Okay, means that I'm just purely calculating only for a 3 and purely calculating for 4. Since they are both disjoint, okay, disjoint output, then I can purely add them together to get the total probability. Okay, yeah, that's what we can do it with the mutually exclusive outcomes or the disjoint events. Okay, fine. See again, addition rule for the disjoint outcomes. If A1 and A2 are represent two disjoint outcomes, then probability that one of them occur is given by the probability of A1 or A2 is simple, A for A2. Okay. And if there are disjoint outcomes, something like which are long list, then the probability will be completely P of A1, A2, A2 up to till AK. Until AK are the outcomes and which are totally disjoint. Then yeah. The statistician really work with the individual outcomes, instead consider a set of collections actually. Okay, so what happens here, we generally don't work on truly outcome, and I think we discussed about the events enough in the earlier slides. Okay, so yeah, for example 1 to 2 3 4 4 5 x, if this is our outcome, so generally what I call A is my event with having 1 2, and B is my one more event having 4 5 6 as an outcome. Okay, so generally we don't work on the individual outcomes, rather we are going to collect collection of the events we work, and we try to calculate the probability for that whole collection of the outcomes. Okay, that's what the meaning of this. Then this is my general addition rule. Okay, if A and B are two events, disjoint or not, okay, means that earlier what we had considered a probability of A or B, when they are disjoint, they are just pure addition. Okay, probability of A plus the probability of B. Now they are not disjoint. Suppose now the condition is that they are not disjoint. If they are not disjoint, then I have to go for subtracting the probability of A and B. Okay, so this is the your general addition rule. Fine. See, the rather this could be explained in the form of the what we call I just forgot the name. So in the terms of sets also we'll be able to explain more on this. For example, if this is my A and this is my B. Okay, now if I want to know what is the area for A union B, this is rather A or B, this will be my area. Okay, now this intersection part is nothing but A and B, which we need to remove it actually. Okay, so that we'll get the complete of this. That is the reason we just remove this A minus A and B. Okay, fine. Then we'll talk about probability distributions in the next class. I think today this much is enough. Okay, fine. Okay. Pawan, Vinay, if you have any questions, today I'll stop.
No, sir.
Yeah, okay, okay. Thank you. Okay, bye.
Sir, resume, sir.
Okay, yeah, today you sent that WhatsApp message. I saw that. Okay, I will I will forward. Okay, no issues. Okay. Sorry, okay.
Sir, one small suggestion, sir.
Huh?
One small suggestion, sir.
Yeah, tell me.
I have 1.2 years gap, sir.
What is that?
I have 1.2 years gap, sir. Previously, I have worked 3 years for a core-based company.
No, still I'm not getting. You have 1.2 years of experience.
Total,
What
I
do you
have
totally you
starting. I
have?
started my career. Starting, I have career started with 3 years, sir.
Okay,
That's is
three.
core side, sir.
So when did you passed out?
2018.
2000?
18.
Okay, 2018. Now it is
Yeah,
23, right? So
yeah,
18, 19, 20, 21, 22, 23. So you have around more than 4 years of experience, no?
yeah, yeah. Before
Okay.
3 years, I have genuine experience for core side mechanical field, sir.
No, remove all that. Okay, remove all that, and truly whatever right now you're doing it right. So you consider all that 4+ years of experience and create the resume. Okay, only that you need to have a good knowledge and some good projects. Okay, and just showcase that only, and probably yeah, of course. See, there are lots of things. No, you should be able to get a job. Yeah. Now tell me what is your question? Sorry.
Sir, I need to mention 4 years experience or 1 year experience. That's why I'm
Yeah, no. Why you mention 1 year? You say that 4 years experience I have, and
yeah, yeah.
in the mechanical also whatever you have worked, right? You just showcase that mainly on you're working on Excel analytics and all that, something like that.
I
Okay.
mentioned SQL database.
Yeah, that is also good. SQL database. Probably you might be working on the records there and mainly on the queries part. Okay, all that we can create some kind of the detailing and showcase that only there.
And data science will be 1.2 years, sir.
Yeah, again that is also data science only. No, like what you are working on SQL.
Yeah, yeah.
Correct. So
Yes.
you say that your career started with the data science only. Earlier, when I was in which company was that?
One climate control, sir.
Yeah.
Kia vendor company. Kia
Yeah,
Motors vendor
purely,
company.
yeah, just to tell, give all the roles and responsibility what you executed there. Probably looking to the related to the DB, maybe the administrative activities also, and also you just showcase that on a Excel, I used to report something like on this analytics and all that. All that responsibility can list it everything. Okay, generally when you create your resume, what you will have, what you have worked, what were your responsibilities. Correct? No.
Yes.
Yeah, same thing. See, we have to go with the data science only. Don't differentiate between that and this. Your career started with the data science. Right now you have 4+ years of experience.
Oh,
Okay.
yeah, okay, sir.
Okay. Fine.
How
Okay.
many project I need to mention in that career? Total 4 years.
In the 4 years means there you create the responsibility. See, that was part of your work or the job or the project, whatever you mentioned in that. After that, you need to where you are working. If even if you are not working, you need to create something dummy. I should not recommend this, but still, most of the people are doing like that only. That's what means that you create that some kind of strong projects, then keep only few things. Okay, don't get into more. Hmm?
Oh,
Simple things, because don't mix between many companies. Okay, let's retain only one company. After that 1.5 year, I moved into this company. Right now I'm working here only, and this is what in last 3 months I already left my job and looking for a new job.
yeah, okay.
Correct?
Yeah, okay, sir. Correct, sir.
Okay, yeah, you should clearly say that you have left the job in last 3 months back.
Yeah, okay, sir.
Okay, so that if you are still working means that again all those formality will start from old company and the new company. Okay, there you will have a problem.
Okay.
Hmm? Okay,
Okay.
okay, fine. Thank you. Bye.